It has been so long since I made a video like this. Hello YouTube, I'm back with a fresh new video for you to see. And it's all about spinning things. To start, we get ourselves our lovely friend, the circle. We all know the circle split into 360 degrees, but for the purpose of physics, we need to use something else known as the radian. We use radians over degrees because they make the math better. The number of radians in a circle refers to the number of times you can fit the radius into the circumference. With that, you find that there are 2 pi radians in any given circle. In physics, we represent an angle with the symbol theta, or as delta theta if we're talking about a change in said angle. And as we change theta, we can see that we have an arc here. You can find the length of this arc with the formula arc length equals to the radius times the change in theta. If we set theta to 2 pi radians and substitute in, we see that we get the formula for the circumference of a circle. Now let's make it spin. We can represent the angular speed with a lowercase omega, and we can represent it as the formula angular speed equals the change in theta over the change in time. And if we add a direction vector, we get angular velocity. If we were to stop our circle as it spins, we see that there's a constant velocity. This is our tangential velocity. It is the instantaneous velocity at any given point of time, and is always tangent to our circle. We can get this number by getting the amount of radians moved over the time it took to do so. We can represent our change in arc as our change in theta multiplied by our radius, which finally we can simplify as the radius times the angular velocity, giving ourselves this final formula. If the angular velocity changes, we get angular acceleration, which you can represent this with our formula. Angular acceleration is equal to the change in angular velocity over the change in time. Note that we're using the Greek letter alpha and not the letter A, which is for linear acceleration. Like our tangential velocity, there is also a tangential acceleration. We can get this by multiplying our angular acceleration by our circle's radius, which we can represent as this formula. Now let's spin this circle at a constant velocity. I'm going to use this camera I have in order to capture our tangential velocity. When I layer these two images together, you can see that even though our angular velocity hasn't changed, the direction of our velocities has. Since there is a change in velocity, we have an acceleration here. Specifically, we have centripetal acceleration, which constantly changes velocity towards the center of our circle. We can find our centripetal acceleration with the formula centripetal acceleration is equal to tangential velocity squared over the radius, which you can also represent as centripetal acceleration is equal to radius times the angular velocity squared. We can see that if we remove centripetal acceleration, our object just flies off linearly, which shows that centripetal acceleration is what creates circular motion. Alright, now you know the very basics to rotational kinematics. Don't forget to like and subscribe, and help me reach 10,000 subscribers very soon. And with that, I'll see you guys eventually.